Good morning, one and all. Welcome to the valuable session from pantechelearning. Today, I would like to deal about webinar on PCB designing, which is nothing but printed circuit boards. Okay, today we'll go with that printed circuit boards and let's have a valuable discussion with that. Okay, without any laggings, let me go on through the introduction and I'll start the presentation. Okay, firstly, I would like to thank the sponsors of this presentation, which are nothing but Sharad Institute of Technology College of Engineering. So thank you ma'am and sir, whoever participated in this presentation for joining here. Okay, so today webinar on PCB designing and its applications. So I'll cover the applications as well as the designing. So I thought you already done with my last presentation, which is on PCB designing, but compared to that I improved a lot. Apart from that, I made a changes of so many things, which is nothing but creation of one PCB design as well as the applications too. So today we'll discuss all the things. Before, let me thank the principal of this college, Dr. S.A. Kota sir, and to the HOD of this college, Dr. S.T. Jadhav sir. So thanks for giving this opportunity. And apart from that, to the convincer, Mr. Sachin S. Sachin sir, and to the coordinator Mr. M.S. Sonali, and to the coordinator Mr. Rohan sir. So I'm thanking you everyone for giving this such an opportunity to share the knowledge on PCB designing. So this is one of the trending technology what we are working on it. Okay, so please be prepared for the technologies and the instructions whatever we have. So don't worry about it. So just be with me and I'll show the way of PCB. Okay, thanks for coming. So once again, good morning to all, and to the Telangana peoples, happy Telangana Formation Day. Thank you. This is Mohan Sai and from pantechelearning. So without any laggings, let's go with printed circuit boards, which is nothing but PCB. So let me go with a short introduction, like a brief history on PCB. So it was started in 1936. So it's okay. Don't go with the area and all. So what is PCB? Before that, I can say PCB are the backbones of modern day electronics. Okay, modern day electronic devices. So for modern day electronic devices, PCBs are acts as backbones. So I can say there are backbones, right? So let's see how they are acting as backbones. Okay, now in olden days, the connections is on point-to-point connections, and it's complicated to manufacture, and the increasing time will be more in order to manufacture one certain device, which is nothing but a TV or something like that. In order to create to connect that circuit, we need point-to-point connections, we need complexity in manufacturing, and we need more time. So in order to this, one scientist so-called Paul Elisser, who is the first man to discover PCB, he designed a PCB with the help of copper wires, and connected each and component with the help of those wires. So this technology, he invented a printing conductivity copper circuit on a non-conductive and connecting components to the threads, which is an olden technology that was ever made for the first time. So what is the idea? In order, he has picked a board in that which is a copper board. He designed a few layers for it, few layers in the sense few lines for it. So in those lines, he connected each and every component which was used before. So these lines, those wires into lines made a change from olden technology to new technology, so called PCB. You got it right? So in early days, what we are using, we use only wires to connect each and every component. But now we are using one copper line. So that copper line is a new era for PCB. That is what I can say. So here, let's go with the introduction part. This is a brief history. I'll show him. He's a great scientist, right? We have to thank him for getting this much technology to us, right? So firstly, a printed circuit board mechanically support, as I said, and electrically connects each and every electronic component through traces. Okay, for that pad, each and every board, it has some traces of copper wires. So each and every component is connected to that copper wire and they are working according to it. So we can make a communication between one component to another component with the help of these copper wires. Okay, so that is what I can say. Now the printed circuit boards is used early on 1930s. As I said, it was first technology which was started in 1930s, right? So here the applications is many more. So most the medical devices are using high density PCBs which has many layers and to use in a particular era. So this is the basic introduction what I can say about PCB. So let's go it one by one. So here you can see, let's consider one mobile phone. So your mobile phone has so many components such as camera, GPS, microprocessors and microcontrollers, many more things. So all the chipsets need one backbone to connect with each other, right? So that backbone we can easily call it as PCB, printed circuit board. So why printed circuit board? Each and every line which is nothing but copper line is printed on that board depending on the need. I'll show one by one, don't worry about that. But in order to go into deep, you have to stay here itself. Okay, this is why I said it's a backbone, because in order to maintain all this and in order to make a stand for this, it acts as a backbone. So that is the simple explanation. So the fact you don't know is in your mobile phone, as I said, you have PCB, right? And it connects with each and every copper line, right? So that copper wire length is around 50 to 30 kilometers. Okay, that much ranged copper wire is inbuilt in our mobile phones in the form of PCB. Okay, printed forms. Okay, now as I said, it was started with Paul Eliezer. He's a great scientist who have invented. So you can see these are the old technology. Wait, let me show this. So you can see these are the connections as I said. So what he made, he arranged a board here itself and he connected that plate here itself, that component here itself, and in that board only he created one wire. So for that wire he created another component here itself. So that is what we call as board, printed circuit board. Here now we are printing in technology of printing, right? So that's why they are calling us printed circuit boards. Okay, so the first man who made that one is Paul Eliezer. So if anyone asks the question like that, you can use his name. And let's see how these boards are developed into these boards. Okay, these are made by Paul Eliezer and these are made by engineers like us. So let's go with how to do this with your home. Like today I'll explain how to design a PC board in your home itself. If you have a equipment with that, we need a few components in order to design one PCB. That's it. So I'll introduce that one, don't worry about that. So before that, let us introduce the types inside in it. Okay, let's go with types. So what are the types in PCB? Okay, so far you cleared, right? If you are clear, please let me know. Yes, if I was going fast means let me know, I'll slow down. Okay, it's completely your wish. If you are okay or not, let me know. Okay, so we can move on this. Okay, so now what are the different types of PCBs? So what are the PCBs we have? So please concentrate on each and every different type. I'll explain each and everything in detail. Okay, don't worry about that. I'll explain each and everything in detail. So firstly, the name so-called single sided PCB or single layered PCB. Okay, yes, thanks for your replies. Yes, fine. So let's go with types. So here you can concentrate the different types of PCBs. Single sided PCB or single layered PCB. And we have double sided PCB, double layer PCB. So both are same. So here single layered PCB, double layer PCB, multiple layer PCB, rigid PCB, flexible PCB and rigid as well as flexible PCB. It's a combination of the sixth one is the combination of rigid and flexible PCB. So let's go with one by one in detail. Okay, yeah, okay, right? Let's go. So single layered PCB, which is nothing but, I think if you are done with your BTech project, you definitely do this PCB. If you are electrical student or electronic student, you definitely do this PCB. Single sided PCB is nothing but it only consists of one sided layer. It depends on conductivity only on one side. Okay, the entire conductivity or the lines are only on side. It doesn't have any holes in order to connect from other side. Okay, single layer stands for only it has one side connections with copper wires. So whatever whenever I use the word connections means it's because the only help of copper wire. So let's see how it happened in the coming session, in the coming slides. But first see the different types what we have in our existing technologies. Okay, single sided. So what are the best thing in single sided? So it is low cost PCB, and as well as it's simple because it only have one side, right? As well as it's of low cost. We can only we have to buy this liquid which is nothing but a chemical chemi-resist which can eat that copper, and we have to buy one copper element. Okay, so if you buy these things, if you have any circuit with you, you can draw there, and whenever you dip this one in that chemical, it will automatically eat that entire copper. Only the sketched parts what you have drawn with the sketch will be remained constant. So we'll see that in detail, but before that, this is what even I have done this one in my engineering days. So like that, if you are done with that, this is what single layer PCB means. Now double layer PCB. So double layer PCB is nothing but it is the same with single layer PCB, but the connections are having two sides. One with the help of through hole PCB. Okay, we'll punch one hole in that PCB so that we can connect from back side too. So we can access from above as well as back side. We can short them in back side. So here whenever you are trying to make two connections from upside to downside, so that is what double sided PCB. Okay, so what is the difference between single side and double side means? That's it. It consists of holes and all, so that we can connect, we can add one more side in order to make some connections to other components. Okay, that is what double sided PCB. So here we have two processes in order to make PCB, right? So the first one is through hole PCB, which is nothing but we can mount that one with the help of holes. We can mount all the components with the help of holes. But the second one is surface mounting. So surface mounting is nothing but only the surface part will be mounted. Mounting is nothing but adding components. Will add components on the surface part. So all the surface will be mechanized, which is nothing but robotized. I can say which is machinery. We humans can't do that machinery because it's so sensitive as well as hard to process. So that's why we invented so many devices for that. But for this single layer and double layer, we can prove because in olden days we doesn't consist of any devices, right? So that is what I can say. Okay, so everything is possible by human. In order to make some less efficiency, high efficiency, we using machines. That's it. Okay, now multi-layered PCB. Multi-layered PCBs are nothing but if you use more than two layers, layers in the sense more than two sheets, two PCBs in one form, and you inducted those two with one insulator in order to not to circuited gets short circuited with each other. We use one insulator in between these two boards. So if any board have more than two layers, that is what we call as multiple layer PCB. So best example is your mobile phone. In your mobile phone we have one PCB. You can't see right now, but each and every electronic device is inbuilt prepared with this PCBs only. So they have a capacity of 8 to 10 layers. Okay, depending on the technologies, they are providing up to 12 layers. Now we can see 8 to 12 layers in our PCBs, in our mobile phones as well as laptops or all. Okay, so that is what multiple layer PCB stands for. Now rigid PCB. Rigid PCBs are nothing but the best example is a computer itself. So computer motherboard is a rigid PCB, which is nothing but a complex one. It can be one layered or up to 8 layers. So we can design this rigid PCB with the help of one layer as well as up to 8 layers. We can expand this one with up to 8 layers, but that purely depends on usage. Okay, the technologies what we are using, the motherboards what we are using is of 8 to 12 layers, as I said. Okay, so these are fully computerized. So the design and as well as the printing is purely depends on the computer and the manufacturer. Okay, this is so much complex, so that's why we use computers in order to make it accurate. Okay, that is what rigid PCB for you. And flexible PCB, I think you have seen flexible PCBs anywhere. So what are flexible PCB? Flexible PCBs are nothing but which has a capacity of move. Okay, which are easily move as well as which can bend. That is simply I can say. So we can make that one with the help of fiber as well as plastic. Okay, so what are the needs for flexible PCB? It should foldable. So what is the first important? Flexible PCB is foldable. What is the advantage compared to other PCBs? Flexible PCB is foldable and water resistant, which is nothing but waterproof, and shock resistant, and it can perform high temperatures. Okay, we have to develop a PCB which has these three positive points so that we can grab one flexible PCB. So you can see the example here itself. So here you can see it's a PCB, it's a printed circuit board. So we can see the components here itself, but here it has a nature of bending. So we have bending nature so that we can process more and more. So I think you may have got a doubt of where we can see this one. So in LEDs or in toys, the toys will flexible, right? Whenever you are using LED flex, inside there is a circuit. Compulsory there is a circuit in order to light it on and off. But those are flexible because the child should play with that, right? So in that scenario, they'll use the LED lights, which is capable for flexible circuits. So they'll add that LEDs to flexible circuit, and so not only in kids things, but in many more which are operated to it. So let's go with the fantastic example, but not now. So after this, I'll show the example, which is nothing but rigid as well as flexible PCB. So it's a combination of rigid and flexible PCB, which is nothing but we can see this one in a separate application, so called mobile phone. So here you can see how I can define means one board is flexible and other board is constant, which is nothing but rigid. So it's hard to move as well as we can't bend this one, the so-called rigid one. Okay, but we can bend this flexible PCB. So what is the use of this one? So with the help of this one, we can create the best thing which is known as foldable phone. So here whatever the thing is there, it's a rigid part, and the bending part so called flexible PCB. So here we use flexible PCB and here you use rigid PCB. So that is the difference, so that we can create one more phone which is suitable for foldings, right? So that is what I can say flexible PCB. So if you see the application, there is no need of definition, right? So that is what I am showing for you. So this is the most important one. So what is the uses of this one? It reduces size. So you can see a foldable phone is of 200 to 2 to 3 inches, right? Sorry, 10 to 12 inches, right? So if you use this one, we can fold up to 4 inches. We have a capacity of that one. So that is what reducing size stands for. And packing weight should be less. So whenever we are done with this, if we are using this one, these two one, so here the flexible weight is very less, so that the weight will be decreased. So somewhat decreased, right? So that's why we can call it as. So it's a pro thing for us. And where we can see, if you are aware of some doctor things, we can see the same PCB in phase makers. Phase makers is nothing but in heart they'll keep one phase makers, right? So in that they'll use this technology, which is nothing but flexible and rigid PCBs. Okay, so in that only they'll use this one, but it has some small things. So now let's go with what are the assembling processes for PCB. Okay, which is nothing but it has two types of assembling processes, which is nothing but, as I said, through hole PCB. Okay, through hole PCB, which is nothing but which is operated with the help of holes, and which is nothing but, and the last one, surface mounting. It's the latest one, as well as which is nothing but all the components will be applied on the surface itself. So firstly, let's see with how the through hole manufacturing will be happen. So how to prepare one PCB. So before that, I can say a point. if you have capacity of working on this, not capacity, if you have an interest of working on this, you can go through my steps. So I'll show step by step process of working on this, so you can do it in your home itself. So please don't use drillers and all, you can do indirectly. Okay, you just buy less resistant acids and all, so it takes some time to heat that copper wire. Okay, don't use high resistant acids, because I know you are aware of that, but that's fine. So firstly, let's go with through hole mounting. Okay, and the next one is surface mounting, right? So firstly, through hole mounting. Okay, firstly, whenever they pick one board, they'll start with punching the holes, so which are so called register holes, registration holes, which are kept in the corners of the board. So firstly, they'll start with drilling machine, and they'll keep registration holes. So this is the first process in order to identify the board direction. Okay, so that they can print the values, right? So now let's see what is inside the through hole mechanism. So which is nothing but, if you are consider layered PCB which has 4 to 7 or more layers, so it has 3 processes. One is through hole, which is nothing but from top to bottom. So one hole is completely shorted, and the next one is blind wire, which is nothing but which is connected to first layer and to the up to third layer. So this is what we call blind wire. And to the blurred wire, which is nothing but which is shorted inside. So the third layer and fourth layer is shorted inside, right? So that is what we call as blurred layer. So all these things are we won't use, because these are completely machinized, so we can't short those things inside by going. So why I can say this point means, the dimension of the PCB what we are using is of 0.75 millimeters. Okay, the size of that PCB is 0.75 millimeters. In that you can't identify the layers itself. So I have one X-ray image too, I can show the layers inside it, but you can't identify and you can't do this one, but you have to program this one with the help of computer. So the computer can do. So this is what the things, but now we'll go through this. Okay, through holes, which is nothing but from top to bottom. So all the layers are covered inside in it. Okay, so this is the different types in the through hole wire. Okay, so far it cleared, right? If you want me to stop, I'll stop here itself in order to prepare few things for you. If not, I'll go through the next slide, which is nothing but the working process. This is very important, so just be in with. So firstly, after the process, when they are developed that one, so one engineer who is nothing but you and me will design one circuit for it. So depending on the requirement, we'll design one circuit for it. So according to that circuit, so the mission, which is nothing but drilling mission, will keep the holes to that printed circuit boards. Okay, so it is not operated by human itself, so it's a completely machinery thing. Why I said this one means, in order to create some accuracy and in order to increase the time itself. So if you do that thing, so if you are home, as I said, you can do this in home, right? You can't buy this drilling machine, but you can use a small drilling machine which we can punch the holes inside in it. Okay, we can do this because there is no limitations for you. You can do this one. So firstly, you should have one plan on what to do. Okay, you have to design one circuit, and for that circuit, depending on the requirement, you have to draw that circuit inside this board. Okay, so whenever you draw that board, you have to keep holes manually. That's it. So when you are done with drilling boards, so you can see the holes will be look like this. Okay, you can see, right? The holes will be look like this. So depending here, they are making 6 different types of boards. Each one is a board, so with same design. So for mobile phone, each one is same, right? But they need millions of units, right? So that's why they'll design like this. So they'll take one big board, in that they'll design the circles. So after that, they'll go through etching process. Etching process is nothing but whatever the thing we have made a copper board now, in that they'll keep one resistor mask, which is nothing but which can create a lines for it, like this, a lines for it. So these resistor masks will create a connections for it. So whenever you dump in a chemical, apart from these lines, everything will be vanished. Okay, that's why we are using this resistor mask. So only the black thing will be remains unchanged, and remaining thing, whatever the thing outside in it, like the copper, whatever the copper outside in it will be vanished, will be eaten by that chemical, resistive chemical. Okay, so for that process they'll dump in this mission. So now in home we can't buy this one, but in a tub we can do this one. So if you want to proceed in your home itself, but in machinery they'll go through this and they'll dump the board for many times. They'll shake this one upside down, so that all the copper part will be eaten. Only the mask which is covered, the lines will be remains constant. Okay, so far you cleared, right? You got it right? So like that we can remind the traces of copper wire. So whenever we remind the traces of copper wire, the entire thing will be cleaned. Okay, we clear, so it goes to the cleaning process. So whenever we enter to the cleaning process, the entire thing will be cleaned. So after that cleaning process, it enters to one mission, so called optical inspection mission, which is nothing but here we remind some traces, right? Those traces will be checked thoroughly. So in order to make whether the circuit is short circuited or whether the circuit is cutted. So like that they'll check both the things. If any board is with these types of things, which is nothing but broken or short circuited, those board will be in dustbin. So they'll throw that one and they'll start preparing new one. Okay, so that is what that much efficiency should be there in optical inspection machine. So everything will be operated by one human, which is nothing but who is an engineer. He can do that in a minute. Okay, so after that, so you may got a doubt because we have started with a color, right, which is nothing but brown color. But if you have seen or not, every PCB board is on green color. So you may ask a question of why it is in a green color. Okay, so here firstly why they go through the green color means, so from this green color protects that PCB board from oxidation, which is nothing but which is reacts with oxygen and spoils the entire thing. Okay, which is keeps from rusting firstly. So which protects from oxidation and protects from dust as well. So this green color has a capacity of protecting from oxidation as well as dust. And after that they'll apply one solder mask for it. So all the things will be covered inside that green color solder mask. So that is what we call a solder mask mission, which applies traces to it. Traces is nothing but they'll keep components inside in it, like you can see, right? So each and every component will be kept inside in it and a green color mask is applied. So this is open up wrap. So whenever you close, it look like this. But here we can get a doubt of, so without conductivity we can't get an energy from this, right? We can't pass the circuit. So for this scenario they'll go through this one. So whenever they are closed, so they'll apply one more mask for it. So they'll apply one more mask and they'll go through the same acid before. So whenever they go through the acid, so each and everything will be remained. So this part what they are covered will be eaten by that certain chemical, and you have to observe it only reacts with this black one. It won't react with the green one. The green one remains constant, and at the end you will get like this. Okay, only the conducting parts. Apart from that, all the green thing with components will be printed there itself. So here you can test components, traces, pads. So in this scenario, flying probes testing, in this you can see these components will attach each other, and the traces will be tested and the pad will be tested whether it is strong or not. So whenever you are buying a new one, and the fact is you can buy this green color PCB board in any hardware systems itself, in any hardware component store. You can buy directly here itself. So there is no need of making all these things. Everything will be prepared. So they'll keep a name for it. So it's a capacitor and it's a resistor, like that. It's a microcontroller. They'll keep one more position and one name for it. So all the things will be tested in flying probes testing. So whenever it passes this testing, they'll go through soldering, which is nothing but soldering components. Here it one tub consists of liquid tin. So they'll dip that board and they'll pull off. So whenever they dip that board, all the components will be soldered to the certain board itself. So like that they'll manufacture the board itself. So everything will be covered in green color, right? So nothing will be conducted there itself, only the whole part. So they'll dip the whole part. So it is easy to make a soldering kit. Okay, if you are aware of soldering, you can get this one. You can do it manually. If not, what are the process? So they'll dip in liquid tin. So finally we get an output of PCB, printed circuit board. Okay, this is how to make a printed circuit board. So far you cleared, right? Next thing is fully computerized, which is nothing but surface mounting. As I shown something there itself, right? So we'll talk about it. So far you cleared, right? How to do through hole mounting. So all the process what I have shown is through hole mounting, which is nothing but with the help of holes itself. Now let's go with surface mounting devices. So which are the best example is our mobile phone itself. So all the mobile phones and all the computers are surface mounted, because we can't keep components like this in our mobile phone. So it's of a big size, right? So we can't increase our size with the help of these capacitors and resistors. So in our mobile phone, all the components will be nanotechnology. Okay, nano or micro technology. So this technology component should be fixed with the help of machine itself. So human can't fix this one because it's very small in order to touch. So few scientists can fix in order to manufacture, but all the process in manufacturing will done by machines only. Okay, this surface mounting, how I can say means, let's go with the introduction part of surface mounting. It's an electrical assembling used to mount electronic components and the surface of printing circuit boards. So on the surface of printing circuit boards, all the electronic components, as I said, not like the capacitors and resistors what you have seen. It's of size of 0.5 millimeters. So 0.5 millimeters capacitors will be assembled in that surface mounting technology. So in this, electronic manufacturers using surface mounting technology simply means the electronic components are assembled with automated. So as I said, all the components are automated automatically. Okay, not by humans itself. So let's see how they are manufactured. So inside in it, you can see, you can't see this one, but inside whenever you dip the layer, whenever you pick the layer, so you can see the connection of it. So here one microprocessor is connected to the camera itself. So with the help of copper wires. So as I said, PCB stands for connecting a component, one component to another component with the help of copper wire. Okay, printed. We have, so here you can see all these lines are printed, not human traces, not drawn by human traces. We can't draw this much sharp and this much tiny. So all these boards are printed. All these lines are printed in a board. So that's why the board is so called printed circuit board. So according to the circuit, they'll print all these lines, right? So you can see the interface of my controller to camera, right? So like this, each and every component is connected. So here you can observe each and every line is not shorted. So if you shorted that line, the way of communication is messed up and the entire thing will be collapsed. So for that purpose, we are using computers in order to make some accuracy. So computer won't do mistakes, right? So that's why we invented that one. So you can see the clear information here itself. So each and every line is separated with some certain length and they are connected with each other. So like this, in multiple layers, they'll connect each and everything. Now we can't connect in this layer to one more sound sensor like that. So that's why they'll create one more layer. So from that layer through, with the help of through hole mounting, they'll connect to sound sensor, which is nothing but speaker. Okay, they'll connect to speaker with the help of same line, not these lines. So they won't mix up with one another line. Okay, so you can see, as I said, you can't see this one with your naked eye. So in this certain part, if you use an X-ray for that, so you can see the layers inside in it. So these are holes. As I see, you can see these are holes, and this is shorted thing, which is nothing but a component. So if you want to connect a component, so you have to do like this. So you have to make a mechanism according to the traces itself. So if you want to connect any component, so here you can connect a component to component. Here if you placed one capacitor here itself, so the capacitor will act to these both components. if you consider this as a camera and this as a speaker, so like this we can connect inside in it. So you can't see this one, this is completely X-ray scan, so you can't see with, so only this small image is X-rayed. So if you are working with PCB, it should be, you should consist of more patience as well as the knowledge inside in it. So if you shorted at least one wire, the entire thing will be collapsed. So you have to take care about vertical as well as horizontal connections. So that if you want to dig more, you can go through it. That's not a big deal. And at the end, I'll show how to design one PCB in virtually, which is nothing but with the help of one software we can design that one, right? So I'll show that one. So before that, this is the X-ray image of that particular PCB. So you can see it has multiple layers and multiple ways to go on. So you can see multiple layers. So with that each layer and with each line, each and everything is connected with copper wire. So that is what I can say. So here you can see, as I said, in surface mounting, each and every component is of same size. One is 0.5 millimeter and 1 millimeter. That's it. So the length and breadth should be this much. Okay. So each and everything will be soldered carefully. So with the help of machines, we can do all these things. So that is the difference between surface mounting and through hole mounting. In through hole mounting, we can see that directly the components, so called capacitors and resistors and all. But in this, we can't assume what is capacitor and what is resistor. So you can't say the big one is capacitor and small one is resistor. So that is what when you resize any thing into micro or nano, you can't describe the values itself. So it has more capacity than what you are thinking, but the size is very small, which is not visible to naked eye. So this is a pixelized image which was taken in order to understand for us. So we can't see this one. If you want to see, seriously want to see, means if you have any old TVs or any old device, you can open that one and you can see the PCBs inside in it. So in that PCB, whatever the things we are using will be a micro technology itself. So you can see these parts, so that you can clearly understand size actual as well as. So here I'm showing something in visualization, right? But whenever you're done with practical thing, it's different. Okay, so please go through it and please check out whether at least one PCB. So if you know what is PCB, then you can get into it. That is what I'm saying. Okay, now let's go with the final part, which is nothing but applications. Okay, so which are nothing but applications. So let's deal with a one by one application slowly. Okay, you are done with types, right? Let's go with applications, which is nothing but, so far you cleared, right? If you are cleared, I'll go in, which is nothing but applications. If you want any rest of 1 minute, please let me know. Or if you have any questions, please let me know. I'll answer in the middle. Okay. So thanks for your support and all. I am saving so much comments on likes and all. So thank you for everyone who is participating in this one. So now let's get into applications of PCB. So I am saying so much thing, which is nothing but how to create PCB and how to work on with PCB and how to design PCB and all. Now let's go how these PCBs are applied in practical. Okay, so which is nothing but, firstly, the medical devices. Medical devices are nothing but, if you are aware of CT scan and MRI scan, so all these scanning devices must and should possess one circuit, or which is nothing but, to operate the voltage and power what is inside in it, it need one specified directions to flow on, right? So for that, we designed one printed circuit board which can capable for scanning that one. So which is nothing but CT scanning. In that CT scanning, you can see PCB board, and MRI scanning, whatever the scannings we have, we can see the PC boards in any electronic devices. Okay, so this is one application. In medical terms, we can see CT, MRI and ultrasonic sensor. Okay, so all the things are used in medical purpose, and apart from that, LEDs. So I hope everyone will see LEDs in LEDs. Okay, which is nothing but, if you ever went to a festival in your villages, you can see number of LEDs which are placed in the roadsides. So in the form of God or in the form of any design, they'll keep number of LEDs, right? Which is nothing but light emitting diodes. LED stands for. So The best example for you is whenever you visited any jatras or something like that, so you can see a god picturization with the help of LEDs. Either it's a Mahashiva or Ganesh, something like that. So you can see. And have you ever thought how those pictures are manufactured? So only with the help of PCBs, printed circuit boards, one controller is connected to all these LEDs. Not if it is a big one, we can use more and more controllers. But if it is a small one controller is enough to control hundreds and thousands of LEDs. Okay, so they'll light up each and everything in the form of Ganesha or Lord Shiva, and they'll display as a god for you. But inside that LED thing and inside that microcontroller and PCB thing, it's just a blinking of LED. That's it. For it, it's a blinking of LED. But for you, it's a god. So that is the difference what PCBs change. So with the help of PCBs, we can connect to that each and every LED to that microcontroller. So that is the importance of PCB. So each and every LED light will be connected to PCB through that microcontroller only with the help of PCB, printed circuit lines. Okay. So this is what I can say in LEDs. The best example is your when I visited any festivals or something like that, you can see that one easily. So in consumer electronics are nothing but the thing in your hand itself, which is nothing but a laptop or mobile phone or watch. So whatever the things we are using comes under consumer electronics. So in that consumer electronics, I think you don't need any introduction for it. So what are the uses for it? So we use for communication, which is nothing but, and in order to connect with one component to another component, and for home appliances. So which are nothing but in consumers, home appliances is one of it, which is nothing but which can operate the entire home from one place. So if you are ever done with smart home presentation and all, so you can see you can control your light and fan. You can see so many ads. The new technologies is fully on controlling your fan and mobile phone or TV or AC from one place. So for all these things we need one processor. So for the connections to computer and whatever the things you are using, we need one board, which is nothing but printed circuit board, should connect that microcontroller to that fan or AC or switches or whatever you think. Okay, that is what the importance in consumer electronics. So let's go with industrial areas. So I think you are aware of industrial areas and all. So we can see these printed circuit boards in manufacturing equipments, which are nothing but in drillers or something like that. You can see these PCBs. So you can see the entire driller is a mechanical part, right? No, that's not right. So now the technology is fully depends on controllers, right? Microcontrollers, and each and everything will be controlled on by the own. So for these controllers, it need one connection to connect to the certain component, so that the certain operation, which is nothing but a driller or to on and off, it needs some connections, right? So for that purpose we should use one PCB. So roughly you got one point, right? Which is nothing but in order to make some connections with easy purpose. So what is the easy way we have in order to make some connections with any other things, which is nothing but PCBs, printed circuit boards. So if you want to connect one microcontroller with sensor or controllers with any other devices, we only have one choice, so called PCB. So that is what the role in automotive components, which is nothing but we can see in power equipment, which is nothing but power inverters and solar power. So all these things, best example is solar plate itself. So whenever if you are aware of solar plate and all, it's of a complete one plate, right? So in that plate, each and everything will monitored inside it. So each and everything is connected inside it. So you can see the solar panels inside in it, but each and every power will be transmitted to one cell unit. So these connections are held only with the help of PCBs. Okay, so that is what in automotive components. And coming to aerospace components, which is nothing but in equipmental area and navigational area. So in navigational area you can see radars, and so many things, right? So in that aerospace you can see, okay, and monitoring spaces and as well as in communication. So whenever the term communication comes, you must and should require one PCB. So you can fix this point. So whenever the term communication means, you must and should require one board which can connect one form to another form, okay. And moreover, I was saying this point, attendance link will be provided at the end of this session, okay. Don't worry about that, don't wait for it, just concentrate on the topic what you have, okay. So the attendance link will be provided at the end of session, and apart from that they'll ping that message. Don't worry, they'll ping that message at the top, so you can go through that attendance, okay. So please concentrate on the valuable session. If you are aware of this concept, please let me know the topics what I have covered, okay. Like the questions you want, I can answer them, okay. So without any laggings, let's go with the next application, which is nothing but military. Military is nothing but in the military purpose we can see the same thing in navigation as well as communication. But in navigation, in GPS and as well as in radars, we can use these PCBs, okay. If you are aware of radar picture, so which can show the objects inside in it in that particular area, so all the devices unit should be connected to this PCB itself, okay. That is what military. And apart from that, safety and security, which is nothing but example for safety and security cameras, smoke detectors and electronic door locking. So all these things, whatever the thing involve electronics, should possess one printed circuit board in order to make connections, okay. So at the end you got one point, right? So in order to make some connections with one component to another component, we need one board which can capable to sustain at this hard components level, so which can capable for maintaining this board components as well as maintaining the connections between that. So that board we call it as printed circuit board, okay. So in telecommunication is nothing but in telecom towers, yes, you can see in telecom towers. So don't think like all these are machinery and electrical. So everything, whatever the things you are using, if you use more than two components, which are nothing but a resistor or whatever the things you want, so those includes printed circuit boards, okay. Either it is a small board or big board, so it includes, if you want to make some connections with two components, it includes printed circuit boards. So in office, so where can in telecommunication, telecom towers, office communication and LCD displays, okay. These are telecom communications. So here if you want to display something to your friends or like we have some displays, right, what are the TV and all, so all these are consist of PCBs inside in it. So and the last thing is military and defenses, which is nothing but, so in military and defense, what are the basic things? Communication between one another and controlling systems. Controlling system is nothing but controlling the entire machinery, weapons. So for all those weapons we need one, here the thing is PCB. So wherever you go, PCB will follows. That is I can say, okay. And why in instruments, why they'll use in military means in order to monitor and in order to monitor the threads and all. So they'll use this PCB designs in order to make one certain instrument, okay. So you can finally so let me finalize this PCB with this, okay. So far the attendance link is already provided, so in this session, okay. Our guys will ping that one, don't worry. So far you're done, right? So whatever the electronic components you'll take, if you want make connection with one component to another component, we need one board, so called printed circuit board, so which is already printed with copper lines, okay. What is the thing inside in it? Copper line. So at the end of session, I'll ask one question from the entire presentation. So if you answer that one, the lucky winner should get will get one gift from our side. So we'll give one gift either in the form of coupons or something like that. So please prepare for that question. So in this presentation only I'll ask one question, so it should be a technical or that depends on my wish, but the lucky winner get one coupon from us, okay, valuable voucher, okay. Now let's go with the designs what we have. So if you are done with all the presentations and all, like if you are done with the learning thing of PCB, so now let's go with the softwares we have in this PCB. How we can design printed circuit boards in our home itself. I'll show that part now itself. Okay, what are the softwares we have? Protestis and ERES software. It's a best software, the professional tool which was used by many companies, so called Intel or something like that. So everyone will use this one. It's not free offer, but the thing from second to 10, from 2 to 10, all these things are free. For free sources you can design PCB here itself. So that's why I included this one. So this one is not a free one, but we can use mod APK, which is nothing but hacked APK. So it's not that much safe. So if you are feeling that much not that much safe, use these remaining 9 softwares. So if you want to make a screenshot, you can make a screenshot for it. Okay, all these are free in source. You can I got for you guys. If you have any interest, do this. Okay, you can go through it. So let's go with the first one, Protestis. I'll show how to install this one and I'll prepare one printed circuit board. Okay, so if you type S, I'll go through the practical thing. If not, we'll stay here. If you have any questions, you can ask him. You can ask me. You got it right? Please type S if you want to go through the online session, practical session. I'll show with one application and I'll design one app itself, one PCB printed circuit board itself. Okay, for you guys. If you want me to show, I'll show. If not, I'll leave up here itself. Letters are small. Wait, let me magnify this one. So these are, you can see, right? So these 9 are, yes. We'll go with that. So if you want to make a screenshot, you can make a screenshot. These 9 are free of source, and I'll go with the first one. So that's why I'm not zooming this one. Okay. So first let us go with Protestis. Yes. Now, so yes, if you are aware of Protestis, I'll show how to download that one. Firstly, go to Google Chrome and you have to type Protestis 7 professional. Okay, please use this keyword so that you can get mod APK. Like what are you using? Protestus Protestis 7 professional. You can see this, right? Protestis 7 professional. So if you go to that one, the first one, which is nothing but Protestis 7 professional, in that you will get interface like this, and go to the down, and here you can see download. Okay, if you download this one, it will automatically start. If you click that one, it will display one ad. That's fine. So it will start whenever it's done with verification. So here you can see the download will be started. Here you can see, right? So the download will be started. I'm cancelling this one because I already have that Protestis thing. So if you are done with everything, so here you can see the Protestis professional tool. So if you open this one, if you created new thing, if you open this one, the first interface will be look like this. So it's the opening part. So here you can go to file session and you can create new one if you want. If you are already designed with this one, so all these things whatever you can see is common for every tool, for each and every tool. Okay, that's not a big deal. And so now I'll go with the important parts inside in it. So if you want to go with one part, like if you want to add up any components for it, yes, let me finish. So here you can have component mode, the second one, component mode. Okay, in this component mode, here this is what we call parts. Okay, here you have to go to this parts package. So which is nothing but here you have to go with the packages what have inbuilt inside it. So now I'll show how to connect LED lights. I'll blink LED lights. Okay, so for that I want LEDs. So I want LEDs, right? I'll take 4 kinds of LEDs. So I'll take these two. Here you can see, right, LED blue, LED green, LED red, LED. So I'll take these three. So here I can see schematic. So if you want to seriously make a PCB for it, so it must and should require PCB preview. If it doesn't have PCB preview, it's not acceptable. Here you can see, right, PCB preview. But now I'll just show how to draw schematic, right? So I'll go through the simple things. So I've taken a LED blue. Now I'll take LED, 4 different types of LEDs, right? So you have to use capitals LED. So here I'm done with blue LED, right? Let's go with here we are done with LED blue. Now let's go with LED green. Okay, yes, I have taken LED green. Here you can see. And now I'll go with LED red. So don't worry about the components here itself. Okay, all the components you can see the names here. They'll mention the blue green names itself. So we are done with green and blue, right? Now I'll go with red. Okay, I'll take 3 LEDs. So apart from that, what we need one resistor, right? Resistor is very important. So resistor, the shortcut of resistor, RES. So when you are done with resistor, here you can see RES 40, the thing what we use. So it has the PCB preview too. So the size should be what I have shown, 0.4 inches. Okay, like we have done with the components. Now what we have, we want power supply as well as we need power supply as well as one ground unit, right? So for that we have to go to terminal mode. Here you can see terminal mode, this one. So in that terminal mode you can see ground. So you have to use that ground. So here you have to if you click that one, it will give you ground, and you have to again left click that one, it will paste the ground here itself. And what we want one power supply. So if you click that one, if you click again that, you will get power supply. So I'll go with power supply. So the components, let's go to component session. So firstly we should connect resistor, right, for the power supply like this. So please click on this one, left click, and there is no need of dragging. If you click here itself, it will come. You can see, right? So you can adjust the position by moving cursor. If you have mouse, it's easy to you. Okay, so I'll go with the same lines. So I kept red LED. Next I'll go with green LED. So I'll keep green LED here itself, and I'll go with blue LED. Okay, here you can see different types of LEDs and one common ground. So if you want to move that one, you have to you have to drag that one, that's it. So firstly, now how to connect that one. So if you want to make some connections, you should connect like this. So if you drag to the end point, you can connect, you will get a wire. So when you get a wire, you can connect to that red point again. So now whenever you place a cursor there, it will show the red point here itself. So you can connect directly to each and every component. So now I want to connect each and every component, right? You have to follow the traces what we have. The backside traces are there now. You have to follow the traces. Okay, now I'm connecting to ground. I think you there is no need of showing so here you have to connect each and everything properly. Okay, that is what I can say. So I have connected everything. Now you have to check the configurations. So here the light should be digital, not analog. Okay, here you can see the specifications. How to get this one? You have to double click on that one. So whenever you double click on that one, should change the specifications. That is green line, which is 10 megawatts. That's fine. And so everything will be fine. You have to change this one to digital. Okay, so the resistor should be that's it, which is analog only. Fine. So let's see 10K. Now if you are done with this one, let's go with simulation, which is nothing but you have to click this button. So whenever it started simulation, you can see, right? So the red color is on and the left green color is in green color and the blue in blue color. You can see, right? We got output. Okay, we got an output of if you want to magnify this one, I can magnify. Okay, so you can see, right? You can see, right? Whenever you click the button so called run, in the downside, run is in downside, you can see, right? Run. So you can see the red is blinked, green is blinked. So this is what a printed circuit, which is nothing but PCB. So like this we can operate this one to a board. If you have any designs or something like that, you can go through it. Okay, so if you have a board, you can print this circuit and you can blink 3 LEDs. Okay, you have to use the components, which is nothing but resistor, power supply and ground should be these 3 LEDs. So that's it. So there you are done with one PCB with that one, right? So now coming to the funny thing in our session, which is nothing but motivation line. So here today our motivation line is something is better than nothing. So that means it is nothing but if you have started something, that is better than nothing. So whenever you are thinking of working of something, whenever you are done with any work, just think about it. Something is better than nothing. That's it, right? So leaving that alone is different and doing something in it is different. So if you have any works to do, just start it. So here the same line repeats, something is better than nothing. If you start that one, something will happen, right? So that's it. That's I can say. Go through the installation process and work according to it. So thanks for participation. So if you have any struggles or anything to say, you can ask in doubt session. If you have any doubts regarding the presentation and all, please contact this one. Presentation in the sense, if you want to make more connections with us, you can contact to the above numbers what I have displayed. Okay, and now let's go with the yes. So now I would like to talk 5 minutes about Sharad Institute of Technology College of Engineering. So apart from saying as they are my what we call sponsors, here I have one friend who studied there. Now he is an engineer somewhere else, but engineer in the sense he's working as a scientist, not as a scientist, as an engineer, key engineer. But what I can say, the institute enrollment is very nice. If you have a thought of engineering or something like that, you can go through it. A simple thing, what I can suggest from here itself. So it's an autonomous institute. You can it's a certified in 2015 itself. Okay, so you can see the more complexity, and you can find in studies you can find more information which is related to practical, it seems. Okay, so whenever I try to contact him, he'll speak in such a huge manner, nice, a pleasant manner, which feels others to make some happiness. So I don't say this college made him so much proud or something like that, but I can say this college made him somewhat proper. So he's a proper guy. They added more things to that properness. So that is what I can say. If you have a thought of doing engineering and all, just go through this institute and check whether it suits for you or not. So it's just a suggestion as a presenter, that's it. I'm not recommending you to go and apply for this college and all. Okay, that's completely your wish. Education is your wish firstly. So but I can suggest this college is one of the best. Okay, and thanks for joining in this session. You have a registration link in your group itself. Please join in our WhatsApp groups and all. If you want any details about this presentation and PDF, please join in that. They'll share there itself. Okay, and if you have any sessions, you can go doubts, you can go through this. If not, and at 2:30 we have webinar on IoT. So it's an interesting topic and emerging technology too. Please join there. Okay, so they'll provide a nice content for you. Don't worry about that. And myself, Mohan Sai, I'm signing off. So and I can say, so if you want like this more and more, please show some interest towards it, like hitting or subscribing our channel like that. So if I get more subscribers on my video, they'll show more interest on myself, so I can give more and more from my side. So everything is in your hands, just a like button. Okay, it's just a like button for you, but it's a motivation for us. So like that, I'll end up this session. So thanks for giving me such an opportunity, ma'am and sir, from this college, and I'll thank everyone who have joined in this session. And now, so as I said, please think about it. Something is better than nothing. So if you are working on that, just go through it. So thank you. This is what I can say. Please write down our numbers if you want. And yes, please subscribe to our channel. I can ask this for lakhs of times, but it purely depends on your hand itself. So if you want to motivate me, and if you have a time to spend with me, just like a button. That's it. That's enough for me. And I'm done with my time. So I'm signing off. Thanks for spending your time with me. So hope you learned something new today itself. So thank you. So don't worry about certificates. If you have any doubts, you can contact there in our, we have numbers, right? So you can contact there. If not, we have creating so many groups for you. You can join there and you can ask your doubts what you have. Okay, don't worry about certificates and all. Everything will be in your hands, but we need some time to proceed on. Okay, so we are happy with this number, so don't worry. So thanks for the timing what you have spent it. Thank you. I'm signing off. Thank you. My sir. Yeah, fine.